Cybersecurity in the industrial environment. Protection of the OT area. Bastioned facilities. Firewall. There are several types of firewalls. Before configuring them, it is necessary to establish what the policies and rules will be to allow access to the devices. The Demilitarized Zone or DMZ plays a relevant role in security issues. In the context of industrial networks, a firewall, also known as a firewall, is a security tool used to protect industrial control systems, ICS, from potential threats. Firewalls work by monitoring and controlling traffic entering and leaving the network. This is achieved by creating security rules and policies that allow or block certain types of traffic. Additionally, they can also perform other security functions, such as intrusion detection and prevention of malware attacks. They can also provide detailed network activity logs and alerts in case of suspicious activity. It is important to note that industrial firewalls have some differences compared to firewalls used in office networks. Industrial firewalls have to be able to operate in harsh environments, which means they must be able to handle extreme temperatures, vibrations, electromagnetic interference, and other unique challenges present in the industrial environment. In general, firewalls in industrial networks are an important tool to ensure the security and reliability of industrial control systems, helping to protect critical assets and prevent potential financial and reputational losses. A firewall functions as a security barrier between a private network and another network, such as the Internet. Its main function is to filter network traffic, allowing access only to services and resources that have been authorized. To accomplish this, the firewall uses security rules and policies to allow or deny incoming or outgoing traffic. Firewall rules can be based on the source or destination IP address, the port used, the network protocol, and other factors. When a data packet arrives at the firewall examines the information in the packet to determine if it complies with the established rules. If the packet complies with the rules, the packet is allowed to pass through to the private network. If the packet does not comply with the rules, access is denied and an alert or event log may be generated. In addition to filtering network traffic, firewalls can also perform other security functions, such as intrusion detection and prevention, packet inspection for malware, and data encryption. There are different types of firewalls used to protect networks and information systems. Some of the most common types are described below. Network firewalls. This is the most common type of firewall and is used to protect a computer network from potential external threats. Network firewalls operate at the network layer level of the OSI model, controlling the flow of network traffic into and out of the network. Host firewalls, also known as personal firewalls. These are used to protect an individual operating system rather than an entire network. Host firewalls operate at the application layer level of the OSI model and allow users to configure specific rules to control traffic entering and leaving the system. Application firewalls. This type of firewall focuses on protecting a particular application or service, rather than an entire network or system. Application firewalls operate at the application layer level of the OSI model and are used to ensure that only authorized traffic is allowed into a specific application. Next generation firewalls, NGFWs, These are an advanced type of firewalls that combine the functionality of traditional network firewalls with other security features such as intrusion detection and malware prevention. NGFWs operate at the application layer level of the OSI model and use advanced packet inspection techniques to detect threats. Cloud firewalls. These are a type of firewall that runs in the cloud, allowing you to protect applications and services hosted in the cloud. Cloud firewalls operate at the application layer level of the OSI model and offer a scalable and cost-effective solution for protecting applications in the cloud. Policies in a firewall system are a set of rules that define how network traffic should be treated. These policies are an essential part of any network security system, as they provide clear and consistent guidance for making decisions regarding the treatment of network traffic. Firewall policy can be defined at the network level, allowing traffic from one network to another, or at the system level, allowing or denying traffic to specific applications or services. For example, a firewall policy might allow HTTP and HTTPS traffic from any external IP address, but block incoming FTP traffic. There are different types of policies that can be set on a firewall system, including Allow All policy. This policy allows all traffic entering the network, without restrictions. While this may be convenient in some cases, it can also significantly increase the security risk of the network. Block All policy. This policy blocks all incoming and outgoing traffic, except traffic essential for system administration and internal network communications. Allow Only What is Necessary policy. This policy allows traffic that is necessary for the operation of the system and the specific applications running on it, but blocks all unauthorized traffic. Monitoring and Logging policy. This policy allows all traffic entering and leaving the system to be logged and closely monitored, allowing for detailed auditing and analysis of network traffic. It is important to note that the firewall policy must be carefully set and configured to ensure that the network is effectively protected, but without interfering with the legitimate operation of applications and services. In addition, the policy must be updated and reviewed regularly to adapt to changes in the network infrastructure and to address new threats and vulnerabilities. Rules are a fundamental part of any firewall system, as they allow you to define the security policies that will be applied to network traffic. These rules are sets of conditions that are applied to each data packet that passes through the firewall, and are used to determine whether traffic will be allowed or blocked. Rules can be configured to allow or block traffic based on different criteria, such as the source or destination IP address, the source or destination port, the protocol used, the time of day, and more. For example, a rule can be created that allows HTTP traffic, port 80, from a specific IP address, while blocking all incoming traffic from other IP addresses. It is important to note that rule configuration must be careful and precise, as a poorly configured rule could allow unauthorized traffic, potentially putting network security at risk. It is also important to regularly update rules to ensure that they are up to date and cover the latest known threats and vulnerabilities. In addition, some firewall systems allow the creation of specific rules for emergency situations, such as a denial of service, DOS, or malware attack. These rules can be configured to block all incoming and outgoing traffic, or to allow only traffic essential for system recovery. Rules can be configured to allow or block traffic based on different criteria, such as source or destination IP address, source or destination port, protocol used, time of day, and so on. For example, a rule can be created that allows SMTP traffic, port 25, to the email server, but blocks all incoming traffic to the web server, port 80, from unknown IP addresses. It is important that rules are accurate and up-to-date to prevent the possibility of unauthorized traffic entering or leaving the network. Rules can also be configured to allow authorized traffic in emergency situations, such as a denial of service, DOS, attack or malware infection. Some firewall systems also allow the creation of machine learning rules that adapt to traffic behavior over time. These rules can be useful in detecting and preventing more sophisticated threats, such as zero-day attacks. Configuring a firewall can vary depending on the type of firewall and the application or system for which it is being configured. Below are some general steps to follow when configuring a firewall. Identify the services to allow. Before configuring the firewall, it is important to identify the services that should be allowed through the firewall. These services may include email connections, file transfer, remote access, and other services that are necessary for the operation of the system. Set security policies. After identifying the services to allow, security policies need to be established to protect the system. These policies may include defining rules to allow or deny certain types of traffic, creating lists of allowed or denied IP addresses, and configuring alerts and event logs. Configure firewall rules. After security policies are established, firewall rules need to be configured. Rules specify what type of traffic is allowed and what type of traffic is denied. These rules can be based on the network protocol, source and destination port, IP address, and other factors. Configuring network interfaces. Network interfaces must be configured so that the firewall can filter traffic. This may involve setting IP addresses, subnet masks, and other network parameters. Testing and adjusting. Once the firewall is configured, it is important to test it to ensure that it is working properly and adjust the settings if necessary. This may include performing penetration tests to assess the effectiveness of the firewall and adjusting security policies and filtering rules based on the results. It is important to note that configuring a firewall can be a complex process and requires specialized knowledge of network security. If you do not have the necessary experience, it is advisable to seek the help of a network security professional to configure the firewall properly and effectively. It is important to note that configuring a firewall should be a careful and well-planned process, as incorrect configuration can leave the network vulnerable to attacks or can prevent necessary services from running. Therefore, before you begin configuring a firewall, it is important to have a clear understanding of the network's security objectives and the services that need to be protected. In addition to the steps mentioned above, configuring a firewall may also include implementing other security measures, such as data encryption, user authentication, and implementing intrusion detection and prevention systems. It is important to note that configuring a firewall is not a one-time, static task, but rather should be reviewed and updated regularly to ensure that it continues to meet the network's security objectives. Periodically reviewing the firewall configuration can help identify and correct security issues before they become a real threat. Finally, it is important to note that configuring a firewall is only one part of a complete network security program. In addition to the firewall, other security measures should be implemented, such as educating users on safe browsing practices and continuously monitoring the network to quickly detect and respond to any security threats. DMZ stands for Demilitarized Zone, and refers to an area in a computer network that is separated from the rest of the network and is used to host public services, such as email servers, web servers, or application servers. The DMZ is located between the internal network and the external network, and is used to separate network resources that must be protected from untrusted external traffic. Services hosted in the DMZ are accessible from the Internet, but are protected by a firewall that filters traffic and allows only specific traffic that has been defined. By hosting public services in a DMZ, you can reduce the risk that an attack on the external network could compromise the security of internal network resources, since internal resources will not be directly exposed to the external network. Additionally, a DMZ can be used to isolate internal network resources and limit access to only authorized users and systems. It is important to note that the DMZ is not a complete security solution in itself, but should be used as part of a broader security strategy that includes additional security measures such as authentication and data encryption. In addition, the DMZ must be properly configured and managed to ensure that public services hosted within it are adequately protected and do not pose a threat to the security of the internal network.